right, so this gray box sort of summarizes the conclusion that we came to from example 5. If we factor the b value out of the argument of the sine or cosine function, we get something that looks like b times t minus h, the quantity t minus h. And then we can easily read the horizontal shift right off of the formula. Okay, so h is the horizontal shift. So the horizontal shift of the graphs, either sine of bt or cosine of bt, is just h units. All right, so let's take a look at another example. All right, so here we have the cosine of 3t minus pi over 4. Okay, so let's first of all, before we go into this one, actually I'm just going to do green. Okay, so g of t, I'm going to rewrite this by factoring the 3 out of this 3t minus pi over 4. All right, that way I can just read the horizontal shift right off of this, because we're asked to find the period and the horizontal shift. So let's do that. So we get the cosine of, and again, I'm going to factor the 3 out, right? So I'm just dividing everything here in parentheses by 3. So when I do that, if I divide 3t by 3, I just get t. Divide minus pi over 4 by 3, I get pi over 12. Okay, so I'm just factoring that 3 out so that I get something in this form. So it's a cosine function, so I want it to be in this form. Okay, so now b is 3. Okay, so, and I know my h, this is h and this is b, and then I can pretty much just read those. I can figure out what the period is just by taking 2 pi over b, and I can just read the h value right out of there. So now, I can also look at, like I did before, if I forget. Sometimes I forget about this. 2 pi over b is the period. But so, I can go through that reasoning as well. But I think I won't do that. I've got it in the notes, but I think I'm going to skip that. So the period of the function is equal to 2 pi over b, and in this case, b is 3. And the horizontal shift is just that h value. So it's just pi over 12. Okay, pi over 12 to the right, So it's a positive pi over 12. Okay, so I'm shifting it in the positive direction. Notice that this has to be a minus. So if it was, plus h, then it would shift to the other direction. It would shift to the negative direction. So be careful about that. So if you had something that looked like, instead of this, let's say we had h of t is equal to cosine of 3 times t plus pi over 12, okay, then that would have a horizontal shift of minus pi over 12, so to the left, okay, in the negative direction. So just be careful of that. But that's really all this question asks for. In my notes, I guess I graphed it and stuff like that. If you wanted to graph it, you could find the start and end of a period. It's going to start, when 3 times pi minus 3t minus pi over 12 is equal to 0. That will give us the start of a cycle. And so that happens when t is equal to pi over 12, right? So if, let's say this is pi over 12, that's going to be the start of a cycle. And it's a cosine with an amplitude of 1 because our a is 1. So let's just say that this is 1. It's going to start there. And then we can also find the end of a cycle, just because that's where 3 times t minus pi over 12 is equal to 2 pi. Okay, and if you solve this, right, divide both sides by 3 and then add pi over 12, I ended up with t is equal to 3 pi over 4. Okay, so So it ends at 3 pi over 4. 3 pi over 4. And so we could sketch in the I didn't do that very well. I should be dividing it in half and then dividing it in half again, right? And that's what it's going to look like, right? So if I wanted to sketch the function, that's my very sketchy sketch. Okay, this is over t values. Okay, and of course then I would continue on as all sinusoidal functions do. Now there is a name for this value right here. Let me highlight it. There is a name for this value. All right, it's called the phase shift. Okay, it's called the phase shift, and it's an angle. It's not time, it's angle. It's an angular shift. Now, being an electrical engineer, I have, especially in the power industry where we're dealing with three-phase sinusoidal voltage and current waves, I'm very familiar with phase shift. So I think, though, that it makes more sense in the context of the very last example that I have for this section. So it's hard to explain. You can read this little box about phase shift. It's an angular shift, but I think it'll make more sense. The example 7 that I have coming up. So I'm going to save my discussion of that for that. And then I have this little box. It's kind of summarizing everything you need to know. Everything you need to know is right here. It's all put together in one. So if you're going to put one thing on your reference sheet for 9.4 and 9.45, it would be this. All right. So you have the general form of a sine or a cosine function with a, b, h, and k, and how all of those affect the vertical and horizontal translations of the basic sine and cosine function. It's all summarized right here. All right. So, but I want to go through one more example, and I'll meet you for example 7.